Welcome to Digital Communication tutorial. Communication is nothing but exchange of information between 2 points, that is source and destination. Exchange of information means signal. Information bearing quantity, we call it as signal. Signal can be represented either in time domain or frequency domain. We have various types of transforms that is used on signal analysis. They are Fourier series, Fourier Transform, Laplace Transform and Z Transform. All these type of transform converts signal from time domain to frequency domain. One such transform is there which uses time shifting property, that is phase shifting property in time domain only, that is Hilbert Transform. So in this session we will learn the following topics. In this session we learn the following topics: signal representation, types of transform, basics of Fourier transform, Fourier transform of a rectangular pulse, and general definition of Hilbert transform. A time domain signal g of t can be represented in frequency domain by Fourier transform equations as shown. So this equation represents Fourier transform and this equation represents inverse Fourier transform. That means Fourier transform, inverse Fourier transform are complementary to each other. That means a time domain signal is represented in frequency domain by the first equation. If frequency domain signal is available, then it can be, we are able to construct the time domain signal using inverse Fourier transform. So let us consider a rectangular pulse as shown. Here we have to find Fourier transform representation of this signal. Writing the mathematical equation for this signal as shown: g of t is equal to a for t greater than minus t by 2 less than t by 2, 0 otherwise. So now we are going to apply Fourier transform equation for this g of t, which is written as shown. G of t is equal to integration. Here I am going to consider minus t by 2 to t by 2 because the signal exists from minus t by 2 to t by 2 only. So what is the amplitude of the signal from minus t by 2 to t by 2? It is A. So substituting the amplitude of the signal A and then simplifying, we are now going to get the intermediate expression A by j 2 pi f into e to the power of j 2 pi ft minus e to the power of minus j pi ft after applying integration limits. Here we have to observe that this exponential series is in the form of trigonometric formula, that is e to the power of j theta. Therefore here we have to write this formula, this relation to obtain sinc function. So I have here pi ft. In the denominator I have pi f here. So I am going to bring this 2j inside the bracket and I am going to add t factor in the denominator and in the numerator, so that this equivalent formula represent sin pi ft. And rearranging the equation, we'll get the g of f as at sin pi ft by pi ft. So this ratio of sine is called sinc function. So the Fourier transform converts time domain signal into frequency domain signal given by at sinc of ft. Now for various values of f, we are now going to analyze the amplitude of the signal. For f is equal to 1 by t, if I consider here t into 1 by t here, so we are going to get here sin pi. Sin pi is 0, therefore answer is 0 here. Similarly, for f is equal to here, if I substitute 2 by t, I am going to get sin 2 pi divided by 2 pi. Sin 2 pi is 0, therefore I am going to get here 0. So in the same way, we can plot the graph in frequency domain like this. So now, with the help of this Laplace transform, we'll try to understand what is Hilbert transform. In the first section, we are going to understand Hilbert transform in time domain analysis. Let us consider a system with response h of t given by 1 by pi t, where x of t is input and y of t is output, and h of t is response of the system. Hilbert transform is defined like this: when phase angle of all component of a given signal are phase shifted by plus or minus 90, the resulting transform is called Hilbert transform. From the basics of mathematics, here convolution operation is happening. Therefore, I can write the equation y of t is equal to Hilbert transform, that is x cap of t, as shown. So Hilbert transform of x of t is given by x of t convolved with h of t. So what is h of t? h of t is 1 by pi t. Substitute here. Now writing x cap of t in the form of convolutional integral here, integration minus infinity to infinity changing the base from t to tau, x of tau by x of tau into 1 by pi into t minus tau d tau. So rearranging the equation, we will get Hilbert transform of x of t is given by 1 by pi integral minus infinity to infinity x of tau by t minus tau into d tau. This is the equation called Hilbert transform of x of t. Inverse of Hilbert transform exists if I have Hilbert transformed signal, that is x cap of tau or x cap of t. I am able to get the time domain signal original, that is given by minus 1 by pi integral minus infinity to infinity Hilbert transformed signal by t minus tau into d tau. So these two equations are called Hilbert transform pairs. So in the next subsequent section, we will study frequency domain analysis of Hilbert transform, followed by properties of Hilbert transform and some problems on Hilbert transform.